Hello everyone and welcome to a brand new video on the mean arterial pressure or MAP. So let's get into it. What is mean arterial pressure? Well, let's break this down. We know that mean means the average. Mean arterial, so we're dealing with arteries, and pressure. So what we are dealing with here is the average pressure across the arteries during a cardiac cycle. So we're dealing with average pressure in arteries during your cardiac cycle. So what we're dealing is a systole and a diastole. And this is very important parameter for patients for us to understand. So the average arterial pressure through one cardiac cycle. So let's take a look at it. And what I want to do to take a look at it is I want to graph the changes in pressure over various types of vessels that we have. So let's look at some vessel types. Some vessels. Let's look at some pressures. Let's look at some pressures measured in millimeters of mercury. And let's actually start with the vessels, with the types of vessels we're going to take a look at. So let's start in the aorta. The aorta. And then we'll look at some vessels that come off the aorta, some other elastic arteries that we might have in the body. And I'm going to say A for arteries, elastic arteries. Then we'll look at the muscular arteries, getting a little bit of an idea. This will not be perfect, but this muscular arteries. Then we'll look at arterioles. The arterioles. Then we'll go to capillary beds. And then what I'm just going to do is I'm just going to do generally venous system. Okay, just because what we want to do is we really want to focus on the arteries. We really want to focus on this side where we're in arterial land regions there. Now the pressures, I'll go ahead and write out some basic pressures. We'll write out 20, 40, 60, 80, 100, and 120. And let me just go up a little bit higher than 120 because we might need it. Okay, so what we're going to do, we're going to graph some pressure changes. And let's just say we're going to start just a little bit over 100. We'll pulse up to about here. And then we'll come up a little bit higher and we'll pulse. And then we'll pulse one more time a little bit higher, and we're going to fluctuate down around. I actually meant to bring this down just a little bit lower here. Let's bring that just a little bit lower. There we go. And then let's say we pulse a few more times. Okay, and then we'll pulse about there. All right, and then I'm just going to take venous and plunge it down to about like that. Actually, let's make him look a little bit more like that. There we go. Okay, so let's say we have these pressure changes throughout. Now, this is not perfect by any means, but what we're going to do, let's say we have this bottom line here and this top line here, okay? And we have these two lines. And then we go in right kind of down the middle of this and we draw a line. Well, what are these lines? Well, our top gray line, this would be representing systolic pressure, okay, our systolic pressure. And this bottom gray line here, this will reference the diastolic pressure, okay, the diastolic pressure. So what's this green line? That would be our mean arterial pressure, the average pressure across arteries. As we could see, there is a dramatic change between systole and diastole, systolic pressure and diastolic pressure in arteries throughout the body. There's some dramatic changes, differences in that pressure, especially in the more central arteries versus the more peripheral arteries. Pressures are different, but we could see a mean pressure for this kind of give us a better idea of what the pressure we're dealing with is throughout the body, so we can get an average pressure. And that's what mean arterial pressure is. So how do we get that value from a patient? How do we actually find a mean arterial pressure? Well, we need an equation. As always, there are some equations that we need to learn. And one of these equations we're going to learn is that a mean arterial pressure, or MAP, is equal to our diastolic pressure plus our pulse pressure over 3. So you're probably wondering, what in the world is this thing called pulse pressure? Let me show you what a pulse pressure is. Pulse pressure is this space between the systolic and diastolic that we have here. This is called a pulse pressure. Okay, it is the difference between the systolic pressure and the diastolic pressure. So what we could say is pulse pressure is our systolic high pressure minus our diastolic low pressure. We should know what systole and diastole are. So we can calculate those things. So let's just say, for example, we are given a normal, like a normal BP. Let's say we have a normal BP was 120 over 80. Then we have our systolic pressure and we have our diastolic pressure. From that, we can calculate everything we need. Remember, basically, when I had graphed this, I had found the high surge and the low surge. We had our systolic and our diastolic pressure, and we are finding the mean or average pressure of that particular pressure that we've measured. So we have a blood pressure. Now what we want to do is find the average. So let's do some worked examples of these. And I'm going to do 3 examples for ease. And I'm going to start with some example. So let's do an example here. Let's do example 1. And example 1, I'm going to do our normal blood pressure. So let's say we have a blood pressure measured to be 120 over 80. Okay, so that's our normal pressure. So we should have 2 things that we need to be able to find. We need to be able to find our pulse pressures and our mean arterial pressure. So let's find our pulse pressure and our mean arterial pressure. And remember, these are measured in units called millimeters of mercury, which I'm going to write down. Okay, so let's go through this and make sure we can find it. Now, what I want to do is first, let's always just calculate our pulse pressure. Remember, pulse pressure is equal to systolic pressure minus diastolic pressure. So pulse pressure in this case is 120 minus 80. Now, so this, of course, has a pulse pressure that's equal to 40. So 40 millimeters of mercury. Okay, so 40 millimeters of mercury. Now, we know that mean arterial pressure, MAP, is our diastolic pressure. Remember, diastolic pressure plus pulse pressure divided by 3. Okay, so what we have is, let's plug and chug into this equation. We have MAP. We know that diastolic pressure is 80. We know that pulse pressure is 40. So what we do, remember, please excuse my dear Aunt Sally or PEMDAS, we do what's in parentheses first. So 40 divided by 3. Then we add that to 80, and we are going to get a mean arterial pressure that is about 93.33. So that's 93.33 millimeters of mercury. Some people would just say 93. I'm going to say 93.33. When I do the calculation. Okay, so that's one worked example that we have. Okay, let's do another a couple more worked examples, and let's do one where I decide to make the blood pressure a little bit higher. Not extremely high, but let's make it a little bit higher. So let's do example number 2. So here's another example. Now, with example 2, what I'm going to do is blood pressure in this case is going to be 130 over 90. Okay, we want to find pulse pressure. We want to find mean arterial pressure. Okay, now remember, we know that pulse pressure is systolic pressure. Sorry, about wrote it down wrong there. Started writing it down. Systolic pressure minus diastolic pressure. So in this case, we have 130 minus 90. That is, again, 40 millimeters of mercury. So we have 40 millimeters of mercury of pressure. All right, mean arterial pressure, since I'm not going to be as pedantic now, mean arterial pressure, remember, is diastolic pressure plus pulse pressure divided by 3. So in this case, MAP is 90 plus 40 divided by 3. MAP in this case is going to be 103.33. 103.33 millimeters of mercury of pressure. Okay, so that is a little bit higher here, okay, because a higher blood pressure. So obviously, both those parameters are higher. Now, since pulse pressure is the same because I'm increasing the parameters by the same amount, I'm increasing both systolic and diastolic by a factor of 10, just to keep it simple. Okay, now let's do a third example, our last example for today, and that's going to be example 3. Now, in this case, I've taken blood pressure, and I have made it lower, 110 over 70. And we need to find pulse pressure. We need to find mean arterial pressure. Okay, so here we have pulse pressure. Remember, again, systolic pressure minus diastolic pressure. And we can go ahead and calculate that. Again, pulse pressure will be 40 millimeters of mercury. Okay. Now, MAP, remember, mean arterial pressure is diastolic pressure plus pulse pressure divided by 3. Okay. And so in this case, mean arterial pressure is, as you probably guessed, 83.33 millimeters of mercury. Okay, so this is, of course, lower because lower than normal, higher than normal. Okay, so lower than normal here, higher than normal here, and normal here. Okay, so what I like to do, guys, is to work all those examples, and these equations you just have to memorize. It does take time to memorize it, but I do this so you kind of understand why, like I do right here, like this little diagram, especially this, is so we understand why we're gaining an average. It's very important parameter to have for our patients. But guys, this concludes my video on mean arterial pressure. I hope you liked it. If you like videos like this, please leave a like rating. Comments are always appreciated. Let me know what you like. Let me know what you like to see in future videos. But this is always, thank you so much for watching, and I'll see you in the next one.